not quite as much agreement this time, but we're saying, most of us are saying answer number 3. So why 3 and not 2? It already has a negative charge, right? So in the absence of any other electric fields, you could have an object, say a conducting object, that had a negative charge already placed on it. Later we'll talk about methods of charging and discharging. So it already has some negative charge, but now it's also charged and polarized, right? Because there's a separation of charge due to the applied electric field. The electric field is pointing downward. And so once again, the force on the mobile electron C is going to be upward. And so you'll end up with a greater concentration of negative charge on the top than you have on the bottom. So diagram 3 is probably the best choice there. Okay. 4, you have the polarization wrong. 5, we know we can't have any excess charge in the interior of a conductor, right? It's only going to go to the surface. And then 1 and 2 are showing neutral objects. So 3 is the best choice there. Okay. Is there a reason why all the charges don't go to the top? Well, it reaches some equilibrium because, remember, you have the lattice itself, or the ions left over, the ionic cores, attracting the electrons in the first place, right? I mean, so there's going to be some point where you reach a balance, and how much charge builds up here is going to depend on the strength of the electric field. In practice, it's very difficult to have all the charge appear, be concentrated on one particular end. You would need a really high electric field. Okay, but it's just a question of degree. How large is this electric field is going to determine how much charge concentrates on one particular part versus the other. Okay. That's just diagram. There's going to be some. In fact, there's probably going to be some amount of charge on the side, right? But in the uniform electric field, we're going to have a greater concentration toward the top than on the bottom. Okay, so it's a cartoony picture. We're not trying to show complete accuracy, but we're at least getting the basic idea.